Graphing functions using stretches and compressions. Adding a constant to the inputs or outputs of a function changes the position of a graph with respect to the axes, but it does not affect the shape of the graph. We now explore the effects of multiplying the inputs or outputs by some quantity. We can transform the inside input values of a function, or we can transform the outside output values of a function. Each change has a specific effect that can be seen graphically. Vertical stretches and compressions. When we multiply a function by a positive constant, we get a function whose graph is stretched or compressed vertically in relation to the graph of the original function. If the constant is greater than 1, we get a vertical stretch. If the constant is between 0 and 1, then we get a vertical compression. Figure 19 shows a function multiplied by a constant factors 2 and 0.5 and the resulting vertical stretch and compression. So for vertical stretches and compressions, given a function f of x, a new function g of x is equal to a times f of x, where a is a constant, is a vertical stretch or vertical compression of the function of f of x. Now, if the value of a is greater than 1, then the graph is going to be vertically stretched. That means the value of a is 1, 2, 3, 4, 5, 6, and so on. Now, if a is in between 0 and 1, meaning that if it's a fraction in between 0 and 1, or a decimal in between 0 and 1, then the graph will be vertically compressed. Now, if a is less than 0, meaning that if it's a negative number, then there will be a combination of a vertical stretch or compression with a vertical reflection.